Okay, so welcome to Networkers Champ, and on request, we have uploaded a new video which basically covers all interview question and answers on switching technology. This might be the part, partial part, but to have the complete list of interview question and answer on the switching part, right? Follow the video. So the here are the topics. What is VLAN? We will talk about and how to answer it. Usually, interviewer want to know, do you have a proper understanding on the switching technology? Yes or not, right? And this is where they ask follow-up questions. They ask one question, then the follow-up question will be asked to check your further level of knowledge. Okay, cool. So let's get started. And also would request you wherever, if I'm going fast, just pause this video, read it out, the context, right? And just to understand it properly. Okay, so let's get started. The first question they usually ask, what is VLAN and why do we use it? Okay, so you need to understand this. We have actually, all layer three network. We have LAN segment, right? And then the ultimately LAN segment is connected to the router, right? So ultimately, this is a single broadcast domain. If you have a very big broadcast domain, right, it is difficult to manage the network because there would be a lot of broadcast traffic. Unnecessarily, the resources would be utilized, right? So what VLAN does, VLAN breaks broadcast domain logically, okay, to limit the traffic. So ultimately, when we say logically, your topology would remain same, but you would configure the VLAN, right, and assign those VLANs to the interfaces. So ultimately, those that particular interface would be the part of one broadcast domain, and the traffic like our right, our broadcast, DHCP discover message, other broadcast, default broadcast traffic would not go from one broadcast domain to other broadcast domain. So the what is the answer? VLAN breaks the broadcast domain logically. Just remember this, you need to mention, to limit the traffic. Not only to limit the traffic, okay, but there are certain advantages like limit the traffic within a broadcast to save bandwidth and device CPU and memory utilization, because unnecessary traffic would not actually go from one network to another network. So let's say, for example, if these particular this network, right, and think of they are the switches, and then you have the complete network over here, right? So the user over here, okay, if they send the broadcast message, and if you have divided, if you've configured this is as an one broadcast domain, let's say if we assigned VLAN 10 here, so the traffic from this particular machine would remain to this broadcast domain, it will never cross, right? So as soon as, let's say, you have mentioned there 10 VLAN 10, and this basically is the part of VLAN 20. So now 10 and 20 would not communicate. Okay. So this VLAN and this VLAN would not communicate. In order to make them communicate, you have inter VLAN. Okay. Okay, so what advantage you get? We get the first advantage is limit the traffic. Second, proper control. Proper control because you can divide your network segment and assign. Let's say this is for VLAN. VLAN 10 is for HR. Let's say VLAN 20 is for IT. Let's say VLAN 30 is for sales. Right? VLAN 40 is for guest users. So like that, you would actually ultimately segment it, you would ultimately break multiple broadcast domain. So through which we'll have proper control. It enhances the security also, as in if the, let's say, guest user comes to your company, to your network, right, or gets connected to your network, They won't be able to talk to anyone. They won't be able to access anything, only what policy you define for the guest. And the same management. So it is easy to manage the network, right? So that's basically the best answer if someone asks, what is VLAN and why do we use it, right? Follow-up question they may ask, okay, what is native VLAN? Okay, so the native VLAN basically, when we configure the trunk, right, between two switches, when we configure, let's say this is switch one and this is switch two, so by default, this port should be the trunk, right? And uh, all traffic on trunk would be tagged, right, using the trunking protocol. So if you want, so native VLAN is a configured under trunk port to allow untagged frame, right, for a particular that VLAN. So let's say if you configure, for example, native VLAN as a 99 on particular this trunk port on over here, native VLAN 99. So that means all traffic, right, destined or sent to 99 VLAN would be over the trunk would be untagged. Okay. Otherwise, if you don't define the native VLAN here, every packet, every frame would be tagged using ISL or .1Q protocol. Right. So whenever you want to send some untagged frame over the trunk link, you configure the native VLAN, and this is the answer. Okay. Question number two, what is VLAN trunking protocols, right? So there are trunking protocol that you configure just now we discussed, right? So there are two trunking protocol, let's say between this switch and between this switch, right? When you connect, let's say this is switch and this is switch, and when you connect actually this port, right? And you when you make trunk, so why trunking is required? So that the frame should be tagged, right? Initially, right? Because if you talk about normal Ethernet header, it does not have the VLAN value, as in from which VLAN it is coming, right? So when you configure trunk, it uses the ISL protocol or .1Q protocol, right, to tag the VLAN. Okay, let's say for example, you are sending it from VLAN 10. This is VLAN 10, for example, okay, and the traffic has to go over here. Let's say again to VLAN 10 machine. So when the traffic, when switch basically receives, if we are not using these protocols, switch doesn't know from which VLAN it has come, because in normal Ethernet frame there is no information about the VLAN ID, right? And this is where trunking is a process of adding the VLAN to the frame, right? It uses two protocol ISL. It is a Cisco proprietary, right? It adds 26 bytes of header and 4 bytes of trailer, where the trailer contains CRC value also to ensure the data integrity. So ultimately, ISL actually adds 30 bytes of extra header, okay, where the .1Q, it is open standard and it adds only 4 bytes, okay, only 4 bytes of, you know, the information that is basically added. Where does it add actually? So it basically is added between, they also ask where does this, .1Q get added. So let's say this is preamble and this is destination MAC address, this is source MAC address, then you have type or length value, and then you have data, and then you have finally FCS, right? So the .1Q is added between destination MAC address and source MAC address here. So here, this is the field where the .1Q tag is added, right? They may ask actually about their, overall bits. Uh, so as you see, it total the length of that .1Q is 4 bytes just after source address to encapsulate the VLAN ID. The first 2 bytes are used as a TPID. It is called tag protocol identifier, and the value would always same this 0x810. This basically to identify that okay, this is 802.1Q, and then the remaining 2 bytes, like 16 bits, are used for TCI, which is tag control information, 16 bits, out of which 3 bits used for priority, right field, 1 bit for canonical format indicator, and this basically identifies whether it is Ethernet MAC or token ring. And then last 12 bits are used for the VLAN ID to indicate the source of the VLAN, right? So when this switch opens this frame, it checks the .1q header, right? That .1q information, it knows that okay, this because here we have VLAN ID 10, right? So this switch basically knows that okay, this basically frame has come from VLAN 10. So that's the answer if someone asks what is VLAN trunking protocol. Okay, what is VTP, right? VTP basically is used to relay all VLAN information from one switch to another switch using parameters, right? So basically, it if you have multiple switches, for example, I don't want to make this actually video lengthy, but think of this is switch 1, this is switch 2, and this is switch 3, right? And if you create a VLAN over here, let's say you created VLAN from 10 to let's say 30, all VLANs created. So ultimately, what is the option? You would console to the switch, create all the VLANs, you will console to the switch, create all the VLANs, you will console to the switch and create all the VLANs, which is very time consuming. Isn't it a good actually option where you create the VLANs on particular one switch and those VLANs automatically get replicated to a rest of the other switch? It is fantastic feature, isn't it? So this is what VTP does. VLAN trunking protocol. VTP is used to relay all information, VLAN information from one switch to another using few parameters, right? So not only adding, but if you delete one VLAN, let's say if you delete VLAN 10, that would be deleted, right? There are three modes, the VTP modes: server mode, which is by default. Every switch will be in the server mode. They ask what mode actually the switch would be. So by default, it is server mode. VTP, in the server mode, VTP has full control in this mode, and it can add, delete, and modify the VLAN. All VTP information is advertised to other switches in the domain. Another actually mode is client mode. VTP clients do not allow to create, change, or delete any VLANs. Means you cannot create, delete, or add any VLAN on client mode. It only sync with all VLANs and forward it to another switches, right? So whatever VLAN, let's say this is client and this is you have made a server. So whatever VLAN has been received here, it would replicate to other switch. The third mode is transparent mode, right? So VTP, here also we have the full control, but VTP transparent does not participate in VTP. Actually, it becomes a standalone. So that means whatever changes that you are making on the transparent. So for example, you configure this is as a transparent mode, and you create, let's say, VLAN 50. So this 50 VLAN would not be replicated to any switch. Okay, that is why it is local to the network. So, and right, Switch does not synchronize its VLAN database with received advertisement. It can add, delete, and modify the VLAN, but any change in transparent mode will not be forwarded to connected switch. Okay, so that's the question. Another question they may ask, what is VTP pruning? So VTP pruning makes more efficient use of trunk bandwidth by reducing unnecessary flooded traffic. So understand this way. Let's say, for example, this is switch, right? And this switch is connected to another switch over here, and this switch only has a VLAN, let's say, for example, VLAN 10 and VLAN 11, right? So this switch basically, but this switch would receive the information from for all the VLANs from VLAN 10 to 30, right? But only you have active VLAN as in 10 and 11. So ultimately, this switch should receive any update for 10 and 11. Why? What this switch will do to, after receiving any update for, let's say, 12, 13, 14, up to 30? Nothing, right? So this is where the VTP pruning, it is like prune the information. So this switch will say, hey, I have only active VLAN 10 and 11. So any update regarding 10 and 11, you can send it to me. Rest you prune all that, updates for all the VLANs. So this is what actually the VTP pruning is. Next question they ask, what is difference between VTP version 1, version 2, version 3? I mean, this is just, I have though written it down here. you just pause the video and read it everything. You need to understand properly as an before answering. But this is very widely asked question in interviews. What is the VTP difference? VTP version 1, 2, and 3. Okay, so it has basically uh, VTP version 1, which is the version dependent transparent mode. So just I would say this is very good question, and very it could be confusing also, but I'm sure if you read it out properly, you would understand actually what is the difference between them. Okay, so let me just talk little bit about it. So version dependent transparent mode. What it says is if it is in transparent mode only, and if it is VTP version 1, right, matches the VTP version and domain name. So if the switch is running with the VTP version 1, it will, and if it would it would basically receive the information only when the VTP version 1 and domain name matches, otherwise it would discard. But in VTP version 2, forwards the VTP messages without checking those, version and the domain. Similarly, consistency check with the version 2 in case wrong VTP or VLAN command is entered. Okay. Like name or VLAN, it generates the log, but not the in version 1. In version 1, it won't generate the logs. Token ring, so version 2 supports the token ring, but version 1 doesn't support. Unrecognized type length value, right? VTP version 2 switches propagate received configuration change messages out other trunk links, even if the switch supervisor cannot parse, or even though if it doesn't understand the message, it will still advertise it further if you are running VTP version 2. But if it is version 1, it would drop it. Right. Version 3, there are certain, advantages in version 3, like support for extended VLAN. See, in usually in normal in version 1 or version 2, you can not configure or all the VLANs you cannot utilize. Even in VTP server mode also, right? You can configure only up to 1000 and 1000 1 to 1001 VLANs. Other VLANs you cannot utilize it. You have to configure the transparent mode to utilize, right? Version 3 extends that support for the creation and advertising of private VLAN. So version 3 supports private VLAN, right? Improved server authentication in version 3. Protection from the wrong database accidentally being inserted into VTP domain. Interaction with the BTP version 1 and version 2 as well. And ability to be configured on a per port basis. So that's basically the answer. Next question, what is VTP messages? Now, we just now talked about here, they basically VTP messages are sent in, right? So these are the VTP messages, summary advertisement. What is summary advertisement? VTP domain servers send summary advertisement in every 5 minutes, 300 seconds, and every time a VLAN database change occurs, right? The summary advertisement. Basically, the summary advertisement lists and the information about the management domain, including like VTP version, domain name, configuration revision number, timestamp, MD5 encryption, hash code, and then the number of subset advertisements to follow. So that is basically the summary advertisement, which is sent by the server in every 5 minutes. Another basically VTP message is subset advertisement. The VTP domain servers, again, server only sends subset advertisement after a VLAN configuration change occurs. So whenever there is a VLAN change, the subset advertisement is sent, uh, such as like if you have created the VLAN or deleted the VLAN, right? Any suspending or activating a VLAN, changing the name of VLAN or the maximum, let's say MTU changing, that time you would send subset advertisement and this is triggered automatically. Third is advertisement request from client. This is the third message, VTP message, advertisement request from client. This message is sent by only client, right, switch, when it detects any change like VLAN database cleared. So this is the answer of what are the VTP messages. Okay. The very important question from the switching is what is Ether channel and protocols? So you should know anyways what is Ether channel. It bundles the multiple link into one logical bundle, right? It is a mechanism which allows us to use all the links as one bundle connected to another switch instead of using one link which is in forwarding state. So Ether channel basically eliminates that STP, right? Where where STP only allows one link to forward the traffic. Ether channel actually bundles multiple links. Let's say if we have three links between two switches, right? So obviously one would be forwarding and rest two would be blocking. But Ether channel bundles these, three links together and make it as a one, right? So there are two Ether channel protocols, PAGP, which is Port Aggregation Protocol. This is actually a Cisco proprietary, right? And the other protocol is LACP, Link Aggregation Control Protocol. This is open standard. The modes available in with the PAGP is desirable, auto, right? And with the link aggregation LACP, we have active and passive. There is also separate mode which is called on. They may ask a follow-up question, right? What would happen when and what if we make ether channel mode on, right? So they want to ask actually, what if when we configure the ether channel mode as an on, right? What would happen? And where do we normally configure? So we configure mode on usually when other end device is not a switch, right? So let's say, for example, if this is, for example, let's say this is switch and this is another switch, okay? And we have here three links, right? And if you want to bundle these three links, right, you would configure either LACP or, PAGP protocol. But let's say here we have one server, okay? And this server has a multiple actually interfaces. Let's say you have configured three interfaces just for the redundancy purpose. And but this server doesn't understand any BPDU. It doesn't understand any LACP or any PAGP, Ether channel and all, right? But from the switch side, you still want to bundle it. This is where you would use actually the mode on. So we configure mode on usually when other end device is not a switch and it is a server or maybe ASXi server or any device which does not support Ether channel, right? Other difference basically between PAGP, other than these modes difference, LACP actually supports 16 link in a bundle. PAGP supports 8 links, though by default 8 links would be active even in LACP, but it supports up to 16 links. This could be the another difference, and this is what widely ask question. Another, I think, yeah. So I think I am done in this partial or the part one or the partial uh, switching actually interview question and answer. Thank you for watching and do subscribe and like to get more updates, more interesting videos on interview and question and answer. Thank you for watching.